TST and VISI present Reverse Engineering, a new functionality to VISI 2019 R1. Welcome. I will be showcasing VISI's reverse engineering features to show how quick and simple generating surface data from point clouds can be. VISI is broken down into four main steps. The first step is importing or scanning directly into VISI the point cloud data. You can only scan directly into VISI if you have a hexagon roamer arm. The second step is the ability to create the mesh. These commands can all be used in conjunction as separately or as one command using the one-click mesh. The third step is our mesh modification. With these groups of commands, we can then modify our mesh to get it ready to become a surface. The final step is to actually create the surface for this mesh. The point cloud data I currently have on my screen is a scan we took during the 2016 R2 rollouts. And since I already have this point cloud data imported into my VISI, I can go directly to our step 2, creating the mesh. Initially this step was broken into separate commands, but now we can use the one-click mesh to do all of them at once, and then if we have to go back and rerun one of those commands, we can run the individual command afterwards. And as quick as that, we can generate a quick, clean mesh, and then from here we can go into step 3, modifying this mesh. The main thing we want to do here is modify this internal hole so that it's not an odd number, it's a nominal radius size. We can go ahead and confirm this after we set the correct value. The final step now is to actually create the surfacing for this mesh. There are individual commands, but just like with the mesh creation, there's the one-click surface command. This will create a grid and then imprint it into our mesh to then create sections that will generate the surfaces for. One thing nice about these commands is that when you hit preview, it's going to actively update the screen as it's doing its calculations. This way you know the total number of surfaces it's tried up to this point and how many it's actually succeeded in creating. That way you know if it skipped any. You're also not left thinking, is this stuck or is it still running? Because you actually can see it updating as it goes along. This total surface calculation takes about a minute and a half, so I'm going to skip ahead. After hiding the mesh, we are able to see the surfaces we just generated. As you can see, we have the sections for where we imprinted the lines, and each square of mesh is fairly clean. We just need to unite it, and then we're done. And there we go. Now that we have seen how easy it is to create a surface, let's backtrack a bit and go through some of the commands that are often used after generating a mesh model so that we can create better surfaces. This first command is the fill gaps command, and it is very nice to use as it will highlight all the borders of the model, making it very easy to locate any holes. After we finish selecting our borders and holes that we want to keep, we can then go ahead and fill in the rest of these holes. Once this is done, we can then observe the results, and as we see, it generates very good clean mesh. The second command we will look at is the mesh cleanup, which will check the model and cleans any minor issues automatically. Then if there are any major issues, it will identify those areas for you so you can manually fix them. Finally, the final set of commands we will look at are the fit commands. These can be used to set radius sizes, make flat areas, or force blends to be cylindrical. As we saw before with the fit to circle, we can force the radius to a nominal size, and then modify the mesh. Once you finish fitting all the holes on the model, you can then move on to the fit to plane command, which allows you to force areas of mesh onto a flat plane so that the surfaces generated later will also be flat. By using the selection deviation mode, we can then find most of the mesh by angular deviation, and then just use a drag window to highlight the small gaps that have been left behind. Confirming that, we can now hit the preview to see the results and see how it flattens the mesh out. The final fit command we're going to cover is using the fit to cylinder. What this does is it forces blends to take a cylindrical shape, evening out the radius in that area. So as we can see here, we can hit preview, And then you can see that mesh get cleaned up in that radius. Another useful command we will want to run occasionally during step 3 is our alignment. This will orientate our mesh with our 3D solid data. This command can also be used with other meshes and other point clouds to align them with each other. And as simple as this, we have our scanned data and the orientation of our 3D solid. We can then run our analysis compare command to check for any deviations. In VISI, there are two main ways of generating the surface data from the mesh. The first one, which we already saw, involved in printing a grid onto the mesh and then creating a surface from the sections. The other way is by color recognition. VISI can identify a colored area that is generated by running a curvature or draft analysis, and then generating surfaces based off of those colored regions. When generating a surface, we're able to select the individual mesh faces to generate a single surface. Thank you for watching. Please like and subscribe for more videos. You can contact us at 248-922-9293 or visit our website www.tst-software.com.